in this hands-on demo, I will share my knowledge on two important services that are offered by Google Cloud, Google Storage and Google Functions. In fact, this video is to see how to integrate both these services. We are going to deploy a piece of code that gets triggered whenever a new file is added to the Google Storage. So by end of this video, you will learn how to develop a Python code snippet and deploy to Google Functions. You will also learn a little bit about the storage in terms of creating buckets, and we will also finally integrate both functions as well as the storage, right? So what is a use case? The use case here is this. So we will upload a file that contains historical price data of a particular stock. I'm not sure how much exposure you have on the stock market, but it is still okay, right? As soon as the file is uploaded, the function will start analyzing the data, and then it would create a result, right? So that is the basic idea. I mean, this is not a great data analysis demo or something. It will be a very simple analysis based on the input file that we have created. If you want to learn more about the clear background on this data analysis, you can just pause this video and then read whatever is written in this particular slide, right? Anyway, we are going to see this in action in a few seconds. So these are all the activities that we would be performing. So we will create a Google bucket, maybe two buckets, in fact, one for the input and one for the output. And we will develop a Python code. First, we will develop it locally and test it using the Jupyter notebook. And once we are comfortable with the results, we will simply copy paste this into a Google function. I will show you how to develop this and how to deploy this function into Google Cloud. Finally, we will trigger, we will add a trigger to the bucket whenever a file is added, and then it would trigger the function whatever we have deployed, right? So that is the whole purpose of this demo. So let's get into the demo now. Okay, let's see how the HLC file looks like. HLC is nothing but open, high, low, close. So this is how this is a very conventional method the stock market uses for representing any historical price values. So let's see, I have downloaded a particular file. This is for a stock called Infosys in India. So let's see how it looks like inside the file. It's pretty conventional. So you have 5 fields basically: open, high, low, close, and volume, along with the timestamp. So you have the timestamp, and starting with this is actually a daily file, so that's why you see only the date. There is no time actually. So it's end of the day, and what was the open price on the day, and what was the high, low, close, and how much volume it traded, right? Pretty simple one. So this is the one that we are going to use for developing the analysis code using Python. So let's get into the coding part. I'm going to use something called a Jupyter. So that would start an instance here. Python is the easiest language, and in fact, it has got the richest libraries for data analysis. I've been learning this for some time, and I've been using some libraries for my stock analysis as well. I mean, that's enough right now. So let's get into this. Let's start a new one. So this is going to be Python, and I'll be using there are many libraries in fact, and there are quite a common one is the DataFrame that everybody uses. I will also be using the same thing. that is coming from pandas. So I mean, this is not the demo, about how Python works, or how we develop solutions using Python and things like that. So that's not the point. So we will just simply develop this and then see how it works, right? So the idea is that we are going to create a data frame, and we are going to read it from the existing CSV file. The name of the file is daily nsc infi.csv, right? Very simple. So let's not complicate this, and let's see how this file looks like. Yeah, pretty cool, right? So it has read that particular CSV file, and it has listed all the different data, whatever it is there. So the latest date, which is the last trading date in the April, I'm recording this on 3rd of May. So it's just a couple of days back, and this is coming in the first row. So I think we need to reverse this sorting point. So I'm going to use this, let's say df sort values by is equal to timestamp. And we are going to say ascending equal to true. And I'm also going to say in place is equals true, right? So now let's analyze this. Yeah, fair enough. Now we got the first one, which is like in the year of 2000, right? So we have about 20 years worth of data, and by the time it was trading around 130 rupees, and now it is around 715 rupees, right? In last 20 years it has gone down to say 98, 94, 92. Okay, doesn't matter. So that's not what we want right now. So let's clear this cell, right? So the next step is to add couple of columns that what we want to analyze, right? So what we want to analyze is the 200-day moving average, like. So this is called a 200-day moving average. So what are the values of let's say, let me call this as window, and I provide some value like this. This is a constant. If you're not comfortable with 200, if you want to increase it by another 50 or make it 100, whatever you want to do, you just change the variable, right? So that's why it is made it as a variable. Now let me create another column. So if you look at df right now, it has these many columns, right? 6 columns are there. Now I'm going to add one more column. The column name, I'm calling it as SMA. So the idea is we are going to create a moving average. So there is a function for this. It is called rolling. So I'm going to use that. I'm going to apply this rolling function on the close price. So we have different prices, open, high, low, and close, and we are interested only in close. So that is why now I'm creating df.close, and the function is rolling, and one of the parameters for rolling is window. I'm going to say take the variable, right? So this is the variable, and this is actually the name of the parameter, and this is the value of the parameter. And we are also going to say that it is mean. So we have to mention this, right? What is the what exactly you want to calculate, right? Whether it is a mean or you can go with something else. There are many statistical methods that you can use, and we are going with this one. So now let's say how the data frame looks like after adding this particular column, right? So now we have a new column. The first few values are going to be NaN, not a number, because for 200-day moving average, it has to wait for 200 rows first, right? Until then, it will be NaN. and by default data frame will omit the middle of the data frame if the number of rows in this data frame is too high, right? So that is the reason you don't see anything with just eclipse dots. And let's say that it is 200-day moving average. So just for simplicity, I will make it as 10 so that you don't you get clarity, right? So for the first 10 rows, like 80 to 88, right, in 79, okay, 79 to 88, 10 rows. So it is not a number. And from this number onwards, this is actually calculated from the average of the first 10 rows, right? So that average comes here, 109. So our data analysis, what we are going to do is whether this close is greater than this SMA, right? That is what we are going to see to buy a stock. So let's say that Infi is a great stock that you want to enter, you want to buy, you want to invest for long term and things like that. There is no proof, right? So first of all, this method really works. By when you buy the stock, when the close price is greater than SMA, it doesn't mean that the price is not going to come down or something, right? So that is one of the comfort factors, that is one of the parameters that generally people consider. If it is more than 200 SMA, then it is good to buy, if at all you are planning to buy, right? You have to do some fundamental analysis, you have to do a lot of market conditions, whether the trend is okay, all these things. Then you will apply this. This is actually one of the parameters. This is not the only parameter, right? All right, so we are going to use this 200 day SMA. Is actually this 200-day SMA is called a 200-day moving average. So that is why it is called a DMA, right? So now we have come to this. Now we need one more column, whether let's call it as good to enter or good to buy, right? This column will be calculated when the close price is greater than our SMA, right? And we would have, now we have added two columns, one is for SMA, one for good to buy. And let's see the structure now. So if you look at the structure, it says false, false. That means it is not the good time to buy, simply because the first 200 will be NAN. And let's analyze something here. So it is pretty much false everywhere, because the SMA value is greater than 583. So that means it is still under moving average. So let's analyze maybe a little bit of tail, let's say 1000, right? Last 1000 values. And if you see lots of trues, that means you can enter something like this. Like for example, if you are planning to enter in the month of April in 2016, is this a good time? Maybe the first condition says, yes, it is above the SMA. This close price 600 is above this simple moving average. So maybe it clears the condition, right? You get one step, yes, so this condition is met. Maybe you want to consider a couple of more conditions, whether the market is okay, whether the recent quarterly results are okay. So many of the things that you would consider, right? So now what we are planning to do is we just calculate this data frame good to buy column based on the past values, and simply we will write this into another CSV, right? Let's say we will call this as the same name. Let's call this file name as it is same, right? Here we will say it is output.csv, or let's make it as recommendation.csv, right? We just simply run this, and hopefully this file would have been created. Let's go and check. right? So now we're in this folder. So this is the one that we took as input, and we got this recommendation.csv output file got created. Let's see what is there in this file, right? So you get the same output. It has added one more column, right? There is a comma and there is no value in before that. So it means that it has created the index number for you, right? So this particular file is having an index, and it has got the usual, the timestamp, open, high, low, close, volume, and also it has added the SMA and good to buy, right? These values are also added, right? So that is what it says. You remember it was NaN, that means it was not a number. So those values are made as empty. Now we have the other rest of the things are already here, right? So this is pretty much, this is what we are going to achieve in Google Cloud. So now let's get back to Google, right? So let's start creating the buckets and convert this, whatever we have written in Jupyter Notebook, into a proper Python function, so that we don't have these hard-coded values. And then we will see, we will also mention where to really create this output file and what would be the name of the file. All such things we will see in the in Google Cloud right now. It's time to create the buckets what we wanted for our functions and storage to work together. So let's create a couple of buckets. In fact, I'm going into the storage. I'm using console so that it is more easier for you guys to follow. I can even use command prompt using the CLI. We'll also see whether we can use the CLI, right? But for now, let's do this. So now I'm going to create a bucket. This name of the bucket is OHLC. Let's call it as OHLC. And I'm going to, okay, so the bucket name is taken. Let's take OHLC input. Yeah, okay. And I don't want multi-region. I'm just making it as a single region one. I'm okay with the default one. This is standard, fine grind, and rest of the things I'm just making it as default one. So currently it has got no files. We need to upload the file, and we have to see what it does, right, once the file is uploaded. So I'm going back to the browser, and this is created. So now I'm going to create one more bucket, and this time I'm going to call LC, let's call it as output so that it is simple, right? So the file is there. I'm making it as region, and all other things as default ones. Finally we create this bucket. So two buckets are created. So the next step is we're not going to touch this anymore, right? So we will first create the function, and then that function, I will show you what we are going to do, right? I'm going to the functions now. Let's create a new function. Let's call this as a stock filter, right? Or entry finder. Let's call it as entry finder. Okay. And here is where we are going to define the trigger, right? This time we are going to choose the cloud storage. The storage name we have already created. So there are a couple of event types that we need to understand, right? Finalize or create is actually whenever you create a new file in the bucket, or whenever a file is overwritten in that particular bucket, this event will get triggered. When you delete a file, this gets triggered. When you archive, when you are moving the file from your standard bucket to archive bucket, right, this gets triggered. And whenever there are any changes in the metadata, and this gets triggered. By default, we are interested in this one. Whenever a new file is created, that's where we want this to be triggered. This particular function that we are going to write is going to be triggered, right? And it is also asking for the bucket name, obviously, right? And we are saying that OHLC input. If you provide any bucket name which doesn't exist, it will show an error. All right. So I'm just making it as the one which is that something that we created, right? We can use a whole lot of different functions. I'm going to stick to Python basically, and it gives you a template kind of how to deal with the Python based function, especially when it is triggered by a storage, right? Here by default it has got two parameters, event and context, right? Event is nothing but the file that gets impacted, like for example the file which is added or modified or things like that, and it has got its own attributes, something like the name, the bucket, and things like that. In fact, we are interested in just the name and the bucket, right? So these two are the ones that we are going to use. So let's change the name of the function. So we have given a different function here. Let's use the same function name. Let's say entry finder. I have to use underscore here because of Python. So I'm going to make use of, I don't need all of this, right? So let me remove them. So let me say file is nothing but the event, right? In fact, I don't need the file as well. So let's define some constants first. Input file, that will be coming in the event, so we don't need that. What we need first of all is we need to import pandas as PD. We also need to mention this in the requirements. It is just pandas, so that this is actually a container engine. Each function runs in a container engine. So even though it is called as serverless, it is not literally serverless. So it has to run in a container, and the container will be something like a Linux operating system, where Python is already pre-installed. And when you deploy this function, what happens is it actually makes sure that this particular library is installed using pip, and it is available for your application, for your function, right? So that is the concept here. So we are using this pandas. We also need something called GCSFS. Yes, so this is GCS file system. So you don't need to, we are not going to use the library explicitly, but you need this to be imported in order to use it, even if it is implicit, right? So let's see. What we are going to do is, this time we have the file name. First, what we did was we will just take this as it is. We don't need to do anything here. We are just copying and pasting it, right? It's right. So we need to do a little bit of indentation work. We will come back to that. And we also need this, right? I will just copy and paste it here. Now let's apply some proper indentation, right? So now this one is the hard-coded one, so that I need to change, right? I will say file name is equal to, it is part of the event, and the attribute name is name. So I'm sorry. Okay. I will realign it again. So now we need to introduce a variable file name, which is event of name, right? And this file name has to be mentioned here. So when the storage gets the new file uploaded, that will trigger this function. It will also pass on some attributes in the event object. Event object has got this name attribute, and that will carry this file name of the file that was actually added. But this pd.read CSV doesn't understand the file name because there is no root, there is no path, right? And that is the path that we are going to develop right now. Okay, we need a couple of more variables we need to define. So the bucket, let's call it as input bucket, because we need output bucket as well. That will also be part of the input, right? So we have the input bucket and we have the file name. That is the complete route, right? And we are going to form this. There is a specific protocol to be followed, which is called a GS, which is Google Storage, right? So it looks like GS. Let me write it this way. So G path is equal to GS / bucket file name. So this will be the original path, but since we have the name and the input bucket coming from the variables, we are going to replace it here. So we will delete this and we will make it as a placeholder. File name will be another placeholder, right? And then we will format by supplying the parameters here. The first parameter is the bucket name, which is nothing but our input bucket, and the second parameter is the file name, so we will supply the file name. So we get the path, and this time we can use the complete path here in this place, right? That's about it. So we are done with this one. So this is going to stay as it is. This is going to stay as it is. This is all good, but the to CSV we need to modify, right? Because we know the bucket output bucket is different from the input bucket, right? This time it is not going to be part of your event because it is your application specific, right? So we will mention that, which is nothing but OHLC output. So this is what we have created already, and we are going to do the same thing here, right? So this time the path is going to be different. So let's call this as input path, and we will mention the same thing here, right? And we will create an output path as well. So this one is same, all are same. This is input bucket. We will just change it as output bucket. Okay, let's keep the file name as it is. Maybe you can add some more extensions or rename the file, whatever you want, but for simplicity we will just maintain it as it is, right? So we will write to output path, right? So that's about it. So we have the input path where the file is going to be read from, and output path where we are writing the df output into this particular path. So that's all. So we have this pandas and GCSFS, and they are also included here. We are pretty much done. We will just say okay. Now there is an important point. We need to just deploy. First time it will be like create, then from second time onwards it will be a deploy function. So it takes a little while. Okay, so there is a problem. So it says hello GCS here, where we didn't modify this one. So that is the important one. So it should result in an error. Let us see. So it won't allow me to edit while it is trying to deploy. So let us wait. So as expected, it has resulted in an error. It says function failed, expected to contain the function hello GCS. So that is a problem. So we are going to edit this and then redeploy. There's no problem. So the name of the function should be mentioned. So the name of the function is entry finder, and that is the one to be executed. Remember, you can have any number of functions in a single file, right? But you have to tell Google Cloud as to which function is the entry function, right? And the entry function obviously can call the other functions inside this particular class. So there is no problem. So entry finder is the one that we are going to deploy. Let us see this time. So the function is fully deployed. It has not been invocated so far. So that we are going to do. We are not going to trigger this directly because as you can see from here, the trigger is going to come from HLC input. So it is time to transfer the file to OHLC input and see what is happening. So let me go back here. This is my demo folder where I already have the input file, right? I don't think we need this file, so let us remove this. Okay, clear. So now we are having just this file, and this is the file I'm going to transfer to Google Cloud Storage, right? There is a special command called gsutil, right? gsutil is basically Google Storage utility. I'm going to use this command. Rest of it all Linux commands. Like for example, if you want to copy a file, you say cp and then take the file name to where, right? GS, same syntax that we are going to use, which is nothing but your bucket name, OHLC input. So hopefully this should trigger the function whatever we have written. Let us see. So the file is transferred. Now the next step is to watch the log. I'm going to use this time command line interface, which is easy for me as well. The project name I have to mention because my default project is something else, so I have to mention the project name here. Okay, so it is 1700. Yeah, here it is. It says file created. No, that was the old one. So entry finder. There is no print command whatever we have used. We have not used any print command, so we don't see any output at all. Obviously, all we can look for is just the output file got created in OHLC output. Hopefully. So that is what we are going to see now. We can use the same gsutil for listing the files. This time we are going to look for the OHLC output folder. Yeah, so we got this file. So let us transfer this file. Okay, so let's transfer this file to our local machine. Okay. I'm going to copy the file from Google Cloud Storage to my current folder. Okay, if I do it, it will overwrite the existing one. So let me call it as in-fee analysis .csv. Right, it is transferring from Google storage to my local folder. Now let me open this file. Yeah, so the first one is empty header, which is nothing but the ID. Then we have the timestamp, rest of the things whatever we saw in Jupyter Notebook, and we have the SMA and good to buy columns, right? Fantastic. So are you planning to buy in fee? All right, not a good time right now, by the way. All right, so that's how, what we did today. We have created a couple of buckets. We created a function. The function actually gets triggered when a new file is added to the storage, right? And whenever there is a new file, we can take the file and put into pandas, and it does some analysis. It is very basic, but still, we can add more and more indicators. There are plenty of indicators, in fact, like for example crossover or breakup or breakdown. So there are many such conditions that we can keep on adding. And finally, if the output, basically what we are interested is what is the latest. The latest is yesterday's data, like did it meet the condition based on yesterday's data, right? If it says yes, it met all your conditions, and it says this is the ideal time to go for buying this stock, you just go for it, right? So that is the reaction we are going to, that is the action that we are going to take, after doing all this analysis. So that's how we have learned. As usual, let me know your feedback on this one, and we will see in the next video. Thank you very much.